Hello, everyone. Thank you for joining us today for our session on Site Reliability Engineering Fundamentals. My name is Lauren, and I'm the content manager on the Google Cloud community team. I'm excited to be joined today by technical account manager Pamella Canova. Want to say before we get started and diving in that questions are encouraged, so please feel free to add those into the YouTube chat box, and we'll be sure to get to them over chat or live at the end of the session. Okay, with that, Pamela, I'll hand it over to you and we can get started.
Okay, thanks, Lauren. Hi, everyone. I'm Pamela. I'm a technical account manager at Google Cloud in Brazil, and I'm here to present this webinar to you today. And this is to be a SRE Fundamentals webinar. And we're going to share a little bit of what is SRE and how to implement it in your company and how to deepen your knowledge in this area. So let's get started. We're gonna leave like 10 minutes at the end for the questions, so please leave in the comments and I'll address them at the end. And this is me. And this is the introduction to our SRE. This is the topic we're gonna talk about today. Is what is SRE, the key principles of SRE, the practices of SRE, how to get started, and the ways to get help. So let's start with what is SRE? According to Ben Trainer, he's the SRE of the VP of SRE here at Google, and he said, SRE is what happens when you ask a software engineer to design an operations team. So basically, this is getting software engineers to design our IT operations. So this is what he defined as SRE. Um, and SRE is a set of principles and practices that were developed at Google and started at 2003 when Ben joined Google. And he was responsible for a software engineers team that worked at the large scale reliable site at Google. And that's where he started developing this practice. And SRE is also a job, like you can be a site reliability engineer. So it's both a practice and a job role. Let's talk a little bit about the costs of operational costs of software. So most companies, they are typically focused on designing and building their products, but not so much in operating it through the IT operations. So there is an estimate that 40 to 90% of a software cost or a product cost incurs after launching it to operate it. So it's like sometimes 10 times more expensive to maintain and operate a product than launching it. So it's important that the companies can focus in hiring good software developers, but also people responsible for operations. So they don't spend that much after launching with unavailability, and reliability problems. This is a scenario that most companies have. So we have like a proverbial wall in the middle between developers and operators. And developers just build a product as fast as they can and just throw it over the wall, and the operators have to deal with it. So sometimes the operators, they have no experience or knowledge in coding and how the product works, and they spend most of their time trying to first understand the product and then act in solving it. So they have to contact the developers and product team before they can do something. So it's not a very good scenario, a setup. Then there is no harmony, and there's a lot of attrition like between the developers and the operation team, and that's where SRE comes to bring down that wall between these areas. And there are some techniques for working this situation. So before we talk about SRE, To work between business and development, like the product management and the development. Then we have agile practices to work on this wall. And when you talk about the wall between the development and operations, then we have DevOps to work on this. So this is the a little bit about DevOps definition. So DevOps is like a set of practices and culture that intends to bring down the silos in IT development and architecture and everything that involves IT operation. And the key areas they have, first of all, is reducing this organizational silos between development and operations. Second, that we know things are going to break, so it's how to plan and accept failure is a normal. Um, Smaller changes are easier to implement and deploy, so implementing gradual changes reduces the risks and also makes it easier to roll back when we have a problem. And then we want to remove, as far as we can, the human error from the equation. So if we leverage tools and automation, so we can reduce the risk of being human error in the process. And finally, we want to measure everything because it's critical to determine like success in all areas. If we need to measure everything we do, so it's very important. And then the SRE approach to operations. Um, the SRE says that we need to use data to. Oops. Oh, sorry. The SRE says that we need to use data to guide our decisions, and then we need to treat operations as a software engineering problem. We don't need to treat it like it's separate areas. So it's important to treat it as the operations of IT is also a problem of the software development team. So to do that, you need people with software engineering skills in both sides. Like you can't have people writing code only in software development. You need people that are supporting that product after it's launched to also know coding, at least to understand what's happening with the product, and if there is an outage or something, they need to understand it. Sorry, I was moving the slides at the wrong place. Okay, now it's the right slide. Let me just go back there because what I was talking the key areas of DevOps, so then you can watch it later. Sorry. So about the hiring people of that know coding will reduce the problem of having to always ask for help of software developers when you have a problem. So if we have coders like software developers of in all areas, then we can design a more reliable and operable like service architectures and products. And it's also good to have people how to code and automate things. Is that we can accomplish many tasks automatically and avoid having people looking at logs and dashboards all the time if it can be done by coding. Okay. So what do the SRE teams do? So it's like basically SREs write software and design systems that can operate scalably, reliably, and efficiently. And that goes from designing it to operating it. So the SREs are responsible for guiding the architecture of the system, and they also work between like the development and the engineering team. So everyone is on the same page. SRE is also a job function, as I mentioned, so a mindset and like set of approaches to running better products. And it's like a being a constructive pessimism. So the SREs are always hoping for the best, but they always have to plan for the worst. So, as I said about DevOps, what they are, then what's SRE comparing to DevOps? Like, actually, if we look into it, it's some people might say that SRE is a way of implementing DevOps because they have like most of the practices and fundamentals are basically the same. So it's like uh, implementing DevOps with a different perspective, but I think the goal is the same. Is always building scalable and reliable software. So it's always the same, but implemented in different way. And in the next slides, we're gonna talk in these 5 different areas from DevOps how the SRE works to implement them. And the first thing we need to learn about the error budgets, it's like the key principle of SRE is it's very important because if we don't have error budgets, we can estimate our SLO that we go see ahead. So if we look into a more traditional way, like a more like a naive approach to measuring reliability, if we probably look like availability is the good time divided by the total time of a product or a service. And it's very intuitive, so we just divide the good time by the total time and we have a number. But it's a little bit complicated to use this kind of approach if we have distributed systems, if we have microservices, and it's important to have another view of this measurement. So it can be applicable to more modern applications and products. Because like if we have a server that's one server down, it's easy to know if it's a good time and the total time of availability. But if we have like a service that's composed by 3 servers and one is down, is the service down or not, or is it partially down? It's difficult to measure if we only account for the time it's up and not the number of interactions into that application. So the SRE perspective is that we should measure availability, dividing the good interactions by the total interactions we have to a service or a product. So we can have like the way to handle the distributed services and more complex architecture. So then if we have a service that is composed by 3 servers and one is down, then we can measure the number of requests that are arriving to that server, and we can say if it's available or not, and not just by the time of the uptime of the server. I guess many of you have seen this table before. So every company or every product team wants to have like 3 or 4 nines availability to their product, but it's a really complicated thing to have. We have many nuances into looking this table because sometimes we look like this example, we have 99.95% availability, but inside this like 21 minutes, we could have a service unavailable in a month. How much of this service is unavailable? Because sometimes it's not completely down; it's just part of it. So we could have like 10% of the 95% or 1%. So it's important to know if it's like a complete like 100% outage we have or smaller outage, like partial outage, and how we can measure that to make sure we can use the error budget correctly. And as Ben Trainer said, 100% is the wrong reliability target for basically everything, because it's impossible to have any kind of product that's 100% available like all the time forever. Because if we think that it's what we want to achieve is 100%, we will never have time to make testing or like upgrading and implementing any changes in an environment. Then it can never be 100%. Otherwise, like something that will be turned on forever, and that's not what we want. So it's important to understand that we will never have something that's 100% available. And that's where comes the error budget. So the error budget is um, how much we have, how much we want to achieve in availability instead of the 100%. So like how much we need to talk to the product team and the users and the business to understand how much they can afford being unavailable. Sometimes a product is not that critical and it can be like 5% unavailable or 10%. So it's important to work with all the areas from developing to delivering the product. Uh, how much of this can be negotiated? So this is what their budget is, how much I want to compromise from my product to make the changes or to plan for space for like a mistake or anything that can go wrong, an outage, then that comes from the error budget. All the unavailability, planned or unplanned, will come from this budget. And these are some benefits of using error budget. So it's like an incentive for development team and the SRE. So you can find the balance between like how much you can innovate, but how much you're gonna compromise your reliability as well. And also like the dev team, they can manage the risk of doing any change. So they can decide how they're going to spend it. Like if there is a month that they haven't had any outage and they think, oh, maybe then this month we can plan for a upgrade or maintenance change. So they are in charge of like managing the risk of doing some change in the product. Um, and it's also important to use our budgets, but being realistic, because if people put like a totally unrealistic goals for the reliability, then it's impossible to manage their budgets. Like, oh no, I want 99.99, then it's probably you'll never have time to upgrade or test anything in your environment. So, and these are unrealistic goals, probably you will you'll have like software engineers not really motivated to do their work because they don't have that window of like a small window for changing and testing. So they will always be afraid of doing anything because oh, my air budget's too low, and if I do something wrong, I better not do it and just leave it as it is. So it's important to check if it's a realistic goal. And also, the all teams involved in our budgeting, they can polish themselves of how much they are spending or not, so they can plan for things. Like if I'm in the middle of the year and I haven't spent like half of my hour budget, then I can plan what I can do next. So it's important to police police all this process like all the time and work with the risks. And it's also something that's shared between all areas. So the area budget is shared between all of them. It's not something that if something goes wrong, you cannot blame only the devs, you know. So it's important that everyone will assume they are part of this. And these are the terms that probably many of you have seen already. So we have some SLI, SLO, and SLA, and these are related to the error budgeting. So the SLI is the service level indicator. and it's like tell anywhere in time how well your service is doing. So is it accepted or not? How good is it doing? Like how much of the time it's up or not? So it's the like in the real time how you're doing anywhere in time. And the SLO, it's the aggregation of SLI over time. So it's like the equivalent of error budgeting, talking about service level. So it's over time, it says like what my target is and how much of it is, how much of my application or product is up or down. So it says if it's like how bad or good I'm doing over time with my SLIs. And the SLA is the service level agreement. It's more related to business. So it's where it comes to like if I have an outage here at Google and if I break the SLA, then maybe the customer will give us a fine or something. So it's pretty much coming down to like breaking agreements, and probably there is money involved if I don't I don't have a good SLA. So it's pretty much related to business and not so much to availability of the product. So as I said, the SLO is the aggregated SLIs over time, and it's typically measured if we divide the sum of the SLI match over the period of time, then we have a target percentage of SLO. And it's very hard to decide choosing an appropriate SLO, but it's important to try to keep it simple at the beginning if you don't have one, and you work it over time. Because if you have an SLO that's too aggressive, then maybe it's too hard to start. So it's better if you start lower and work with the product and our teams uh, to rise it over time. So it's important that the expectation of the SLO is set between all areas. So before we can launch a product or have it in production environments. And this product lifecycle that we saw previously, then if we have SLOs and SREs, we can solve all the problems between business development and operations. Because then, as we talked, like the agile and DevOps just work separately, two areas. Then with SLO and SRE, we can bring these all three together. And with the SLO and SRE that we talked in this last slide, we can already compare three areas of the DevOps and how the SRE works on it. So in DevOps, reducing organizational silos. Then in SRE, we share the ownership. And instead of accepting, not instead, but to work with failures and accepting them as normal, then we work with error budgets in SRE. And while DevOps try to measure everything, SRE works mostly on measuring reliability of the service. These are the areas of practice of SRE. So we have the metrics and monitoring, the capacity planning, change management, emergency response, and culture. The first one, monitoring and alerting. Then we talked earlier about measuring the SLOs, and that's where monitoring and alerting comes from. So we need to measure how well we're doing against our targets. And then you have to have high quality alerts and systems that only trigger when you think that your error budget is threatened. So it's important that we automate the metric systems and work in determining what's our SLO and SLIs, so they are adjusted to our goals, and that we have proper alerting depending on the severity of an incident or an outage. So it's important that we only require human attention if it's necessary. So if we need immediate interaction of a human, then it's important to have a page or a phone or something that let them know that they have to do something. But if there is no immediate interaction needed, then we can have a ticket system that will work on this, and their an analyst or an engineer will have a look when they have time, depending on the priority of the case. And it's also important that we don't have humans doing work that could be done by coding. So we don't need humans to look at dashboards all the time or looking at logs, and they have to have tools that let them know that something's wrong. We don't need people to do the work of like we can do by computers. So it's important that we can reduce the toil of the operating team if they can only react when it's needed and not looking all the time. If we have like, oh, I'm gonna look at this screen my whole shift and see if something becomes yellow or red. So it's important that we can reduce this toil working, and they can invest time in coding, for example, or doing things that will improve their system instead of just doing a work of like robots could do. Something that's also very important is that we have capacity planning and also forecasting what we're going to use. We can have organic growth that will come from new users or like growth for your website across like over time. But we can also have inorganic growth that will come from launching a new product or a new site. So it's important we plan for both. We have like an estimate and a forecast for both scenarios, so we don't need to react immediately to like, oh, if we don't plan the capacity for a product and we have like a Black Friday or another big event that will increase the capacity, then maybe won't have the resources to increase it when needed. So it's important to plan in advance these changes and also correlate them with the capacity we have. So it's important that we know how much we can grow. So if we don't have enough money or resources, how to organize this. So I need to grow my system like 10 times for a period of a month. How can I plan it? How can I be safe that it will be delivered and I can scale it and I won't run out of resources or I'll have the money to pay. So it's important. And for the organic growth is just like having the metrics over time and analyze them periodically so you can see how much you've grown over the like every 6 months or 3 months or over a year and compare how much you can plan, like so it's a steady 10% every year or it's growing over time, so you can scale your capacity over time as well, so you won't have any problem. And another point of view, talking about this scaling and forecasting, is that we have to think about the efficiency and the performance of our environment, but we need to always think of both sides, because sometimes we overscale things afraid of an upcoming event, and then we are wasting money and resources that aren't used. So resources are very expensive, and then we need to plan for a fair value for like the amount of resources has to be fair. We don't need to overthink and then put too much into it and then we're not gonna use it, and then we are paying for something we're not using. And also, we can't think of like a margin too close. So then we can have a product like degradation and latency and many other problems if we think, oh, it's gonna grow only 10% and then we just cut it too close and it comes down to like you needed 20% and you didn't think you needed. And then you have the users or customers impacted. So it's important to always think of like the capacity and how you can optimize it and not spend too much or be too short on the resources. Always meet in the middle to guarantee your availability in big events or product line launches specifically. It's very important. Another thing that's very important in the process of SRE and in IT in general is change management, because there is a study here in Google that says that 70% of the outages we have were due to changes in the live system. Many people just think they can do changes and that's not a minor change and it won't affect my system. So I'll just do it. Just a line of code is just like I'll just restart the VM or something very small and I think it won't impact my system. So people need to start thinking that it's important to have change management even for the smallest changes. So it's very important that we have the change management culture, and it's very well known inside an organization. So everyone will understand and learn the process of change management and how they can avoid bigger outages. And also, we can have faster rollbacks if there is a problem, if everyone knows how the change is going to be made and all the steps are informed in the change management process. So it's very important that, sorry, that everyone understands that and they can quickly react if there is a problem. And also, in this case, it's possible to remove humans also, just like automating operations. It's also possible to also make changes. So if there is something that we can do by code and avoid that there is a human interaction in the process, then we can reduce the fatigue of the operations team. We can improve velocity because we can implement it any time and we don't depend on humans needing to do it. And we can also reduce errors because then there won't be a human factor in the equation. But we know that humans are not always replaceable by code, but whenever we can do it, we can save time and also remove toil from these people, that we don't need to make people work during like night shifts if it's not really necessary. So they can have a nice sleep and be working at their full the next day. So just think about everyone involved and if we really need to make this or we can automate it somehow and spare some hours. So as like we said before, then 100% is wrong reliability target for everything. So it's important that we determine the reliability of our product and that we are not trying to provide something better than desired. Sometimes, if we say that we have a availability target of 95%, and that's fine with product team and with the user, then we don't need to over deliver what was already agreed. Unless, of course, we can review this over time, but always try to make sure you meet what you've agreed, then trying to over overdo this, and sometimes you do something wrong and you have your SLO at risk. So it's always important that we have achieved what we agreed to do. And also, if we can use the error budget if we don't use it over time, like, oh, it's been 3 months, we haven't had any outage recently. Maybe then we can use the time we haven't used to upgrade something we find, or like we found a bug into an application and we can fix. Like we don't need to be afraid of using the error budget. I mean, like, the goal is having zero outages, but sometimes it's wise to use it if we haven't used it yet to improve the product or the system. So it's good to use the error budget for experiments and testing, or any other scenarios. If like you're being wise, not wasting it with minor incidents, then you can plan for something bigger, and then people will be prepared for it, instead of like, oh, I won't use it now, and then you just go over 6 months without reviewing your application or upgrading it, or like updating this operational system or something. And then because you didn't look at it for 6 months, because it wasn't like there wasn't an instance, then you have a problem, because like, oh, the manufacturer says I have to update the operating system every 3 months, for example, and I haven't done it because there was no outage or anything, so I didn't want to use my error budget. And then comes a bug that the manufacturer saw and told you, but you didn't pay attention, and then you have like a vulnerability or something. Um, Sorry. And then you have an outage. Oh, I just saw like a question from not able to understand the idea of using the error budget. Uh, like, the error budget is the time you have agreed to use for like outages or changes. So if like we have a 95% availability rate, then you have 5% of our budget. The error budget is the part of the SLO that we use for maintenance or implementing changes, or also if you have an incident. So every time you put down the application or the service, will count into that time. So it's the other part of the SLO. So if we have 95% SLO, we have 5% error budget. Is that part is what you are able to use? Because some people, they just think about we have to achieve 9999, but then you don't think you have incidents or changes. So it's always uh, 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 okay. Let me see the other question. An upgradation that requires downtime means the product's not built right. Oh, not always. Sometimes it can be something that comes up after it's delivered. It's not something, I think it can always improve the application or the product. Yeah, well, it's true. If there are some upgrades that can be done with uptime, that if you have a high available application, then you can like put down one node or like a pool or something at a time. But there are sometimes you have to put down a website or something. So it's always something you have to think about. When you develop, if it's something you can afford. Of course, if you have more resources and money, you can think of more reliable and available applications, and you have less of downtime. But sometimes you don't need it. You don't need it, and it's expensive. If it's a product that can handle some downtime, then it's cheaper. So if it's not a problem to have like 30 minutes a month for an application should be down, then it's cheaper for me to operate than paying double, for example, to have two. So it's always something you have to consider, if which scenario fits best your business or the application and the product. Mhm. The next one. And so one thing that's also important between the change management and the capacity planning is provisioning. So uh, how can we, like, we always need, there is always a necessity of upgrading or scaling something. Like we need to, oh, my product's doing very well and I'll have to scale it. So it's very important that we plan for this. And it will be always necessary unless like you over provision, and then it will be less common. But if you plan correctly, then you just have to provision a little bit over time according to the product growth. So it's important not to over provision, as I said, then you are spending money on something you're not using. And sometimes it's also comes part of an outage or something. There are some rollouts that can't be done, or increases that can't be done if the server or application is up. So it's important to plan this and think about the user that's using this product, and we need to do it quickly and with less impact to the final user as possible. And of course, then it has to be done correctly. So ideally, it's important that we have like homologation development, all environments before production that we can test the increase and rollout and upgrades and everything. So it's important that we test it before we do it directly into production. And well, something that's part of the SRE culture is that um, you don't have to be afraid of asking for help because things break. That's life because nothing is perfect, and it's part of the IT world that everything breaks at some point in time. And if it didn't break, something is really wrong with it, or maybe someone never turned off that VM or anything, because eventually they will break during an update, or anything can happen, or like an incident or breach, vulnerability. So just deal with it. That is part of life, and don't panic about it, because we're not alone in this. And well, the world is not ending because of this, and we have to be calm to mitigate and fix the problem. And then after it, we can think of what caused this and what was the root cause. But it's important to be calm and fix it before anything. And like if we are feeling overwhelmed or that we can't do it, we need some help, or we don't have the expertise in a special product, it's always important that we pull more people. Like, oh, this is not something I've written the code and I've worked with this product before. So feel confident that you can reach out to the rest of your teams or like other areas if necessary, because it's more important to have the problem fixed than finding what caused it. So it's always important. Let's fix it first, and then we look at what was the reason it failed. And this is usually what every incident has, at least the ones that someone complains there is an incident, because not all problems need a postmortem, but oops, not problems require a postmortem, but it's important to always have one when you need or someone asks. So it's important that we have all the information regarding like what was the downtime of application, or what was the degradation, what was the threshold for that problem. And if we need to gather all information, like if we had lost any data, if it was lost any money on this, and it's important to have everything to work in this. Like if the person that worked in it has to write down everything about what happened, as much as like all the information you can gather and put it together for a postmortem is relevant. Then when you're writing it, you can filter what's like you feel is necessary, but all the information you can write is important to put together the resolution. So, and also write down a timeline of since the problem started and when it was solved and what was done to fix it is important. So you can write about it afterwards. And it's also important to know what are the thresholds for our service or product, because maybe for a company, if we have a latency of like 10% increase is not an incident for me, but maybe for another company it is. So it's important that we have all the thresholds for each product to declare an incident, because some situation can be an incident for one person, not for the other. Or the business can see it as an incident, but the technical team says it isn't. So it's important to come up with all the thresholds before we can say we have an incident. And about the postmortem philosophy that we have. So it's always important that the incident is very well documented and that we understand all the root causes and everything that happened, so we can explain the very clearly in the postmortem and don't hide any information. Uh, and also, after finding the root cause, we need to write down what fixed it and what we can do to prevent actions like this in the future. So, if it was a mistake made by someone, what we can do, like train someone in the tool or the product so they won't do the same mistake, or if it was a vulnerability of some sort and how we fixed it and how we're gonna prevent it from happening again, like scans and applying fixes. So it's important that everybody understands that the postmortem is a document from the beginning to the end and also the future of an incident and not a punishment. So it's not intended to say who did something, like if it was a person who caused the incident, it's never uh, good to put the person who did it in a postmortem. It's about our culture, so you'll never put the blame on someone. It's not nice if, like, maybe if we try to find the person who caused it, then we can find a bigger problem, like, oh, then this guy did a mistake doing this because he didn't have the proper training that we didn't provide. That's something that can happen. So we always have to assume that the people doing changes, they always have they are never trying to do something wrong, and but things can go wrong, but it's never their intent. Nobody has the intent of doing something in a way to cause an incident. So this is what I was talking about before. Then we have the culture of blamelessness in SRE. So it's like we have to focus on identifying the causes of a problem and indicating how to fix it, but we'll never say that someone was responsible for it. We as a team or as a company, we are responsible for it, and not one single person is responsible for causing an incident. It's all about the culture and the process. Things like the development, the change management, many things can go wrong, or we lack many things that can lead to an incident. So uh, we have to assume that we can't fix people, but we can fix the process and the system. So if someone did something wrong because of a process, then we go there and change that process that led to this. And we never change the person. So it's always important to see it at this angle. And about the operational work is something that I said before. So it's important that we find opportunities to automate everything that we can. I mean, we can't eliminate the human factor in this, but we can think of ways to reduce their toil work by automating things and and also train them in all ways possible to avoid them doing this toil work. That's can people can not like they won't feel motivated to do their work if they only do toil work. And it's important that we have a good team skill set. So it's important that we have software engineers and also system engineers, like um, with the SRE culture in our company. It's very good that from development to operations that everyone can do a little bit of coding. And it's important to empower the SREs. So the SREs they will have to have the power to enforce their budget, and also we need to see that they are valuable and scarce. So we shouldn't waste their time with things that we could do. Like we should get to the SREs with more complex questions and use their time wisely. And also, we have to see like we don't overload them with the information and job that they can't do. Otherwise, it won't. He won't have time to do everything right. So it's important to keep a balance of their work and life. And I think if everyone, not just the SRE, but everyone involved in this process has to have a good balance of work. And talking about the other areas, because we talked about three that we covered with SLO and SRE, and then the with the other two that were missing. So it was we added something. So let's read again. About the failure as normal, then we have the error budgets that I mentioned, and then we have the blameless postmortems that also are part of this. And implementing gradual changes will reduce the cost of failure. And measuring everything, we can measure the reliability and the toil of the operation teams. So these are the four things to start with SRE. The first one is define an SLO is the first thing to do. Hire people that can write code from the beginning to operations. Ensure the culture of SRE is implemented and everyone understands the culture of blamelessness. And also we have to implement a loop of feedback. So we can always have all teams working together and going back if something goes wrong with this, like in the feedback, and work together to fix it. And to start, like everyone can do this. Like you can pick one service and start running this only service according to SRE model. And then you can empower other areas and show the executive team that you can do it, and maybe you can spread this to other services, but you can start with a small one and show it's valuable and doable inside your company, and spread the love to other areas. So if you have the SLOs defined and you have a case study you can share, then you can prove it's possible to implement it. So you have to have the data and everything to prove you can do this, to like you can implement SRE in your company. And the SRE can solve many problems, and mainly the cloud reliability problems. So we can work with other teams to build scale, like we can build scalable and reliable solutions and automate engineering operations. So it's important also to bring the tension down between the development and the operations. As I said, like bring down that wall between them. And we can use the year budgets to bring some flexibility so we can have like the reliability and also the velocity in building new products. You can go to this site. We're gonna put it there in the comments. So if you go to sre.google/resources, you can have access to all books published by Google on SRE and read about them. There is also a Coursera course called Site Reliability Engineering, Measuring and Managing Reliability you can attend. And we have a certification that's called Professional Cloud DevOps Engineer. That's about DevOps and SRE together. If you want to prepare to a certification, you can use the resources and the books I just said. And that's it. I'll have a look at the questions now. Just a second. Let me see if it's something I have unresponded.
Yeah, I just wanted to say thank you so much for that awesome presentation. And that it looks like we answered most of the questions in the chat. But if you have any others, please feel free to add those in now. And then also, we'll definitely be sharing a recap post in the Google Cloud community. And you can find that link in the YouTube description with the key takeaways from the session and the recording. So you can refer back to it later.
Let's see if they sent anything new.
There's one question from Hugo. Is it necessary to be a software engineer to become an SRE?
Yeah, like you don't have to be exactly a software engineer to become an SRE, but you need to know a lot about coding. But it's not necessary to be a software engineer initially, but most of your work will be the one of a software engineer. So you'll have to start studying a lot of coding and stuff that the software engineer do. I mean, you can be an operation person that knows about the SRE practice and everything, but to be an SRE, like the job description, then you have to know a lot about coding.
Got it.
I just saw one here. This was SRE. Oops. This was SRE, but the Google Cloud certification is about DevOps, right? Yes, it is. But as I said, there are many things that SRE and DevOps look at the same thing. Like they talk about the same thing, and some people might say that the SRE is a way of implementing DevOps. So they are very well like close related. So you'll see that the material for this certification talks about SRE and DevOps at the same time.
And we have one more around certification. Right now I'm preparing and pursuing for the ACE certification. Can I pick DevOps certification after this?
Yeah, there is no order or no requirements for certifications here at Google. So you can definitely do the DevOps after, and you don't even need the ACE certification to do it. You can do just DevOps directly if you wish. So there is no requirements. But of course, it's good to have some experience in using and manage cloud products, but it's not necessary to have the certification.
Awesome. And I did want to share, since there are a couple of questions around certifications, that there is a dedicated place in the community, if you didn't know about it, for learning and certification. So if you're running into questions while you're studying, or which exam you should take or which one to pursue, that's a great place to ask your peers and the learning team from Google. So just added that into the chat. All right. It looks like that. Oh, there's one more. Oh, can you please share the site reliability engineering course link on the Coursera platform?
Let me just get it here. Just a second. Oops.
I just dropped it into the
Okay,
chat.
thanks. I was trying to copy it from the slide.
All good. All right. Well, thank you everyone for joining us. We are at the hour, so if you have any other questions, feel free to ask them into the community. I just want to say thank you, Pamela, so much for this amazing presentation and for joining us today. And we hope to see you again another time.
Thank you, everyone.
Thank you. All right. Bye.
Bye.